Hey there! Today I'll show you how absolutely easy it is to add MCP servers to Pydantic AI agents. So recently, Pydantic AI has released support for MCP servers. And if you're on this video, I assume you already know or at least have an idea of what MCP is. But TLDR, MCP is a protocol, a standard way of creating servers that can be used by AI, by LLMs, to extend their functionality, right? So this basically standardizes the way that we do function calling or create tools that can be used by any LLM. And this is quickly becoming the standard way of creating search tools and creating services that can be quickly attached to existing agents or LLMs to extend their functionality. So Pydantic AI has made it extremely simple for us to create and configure this. And it's actually so simple that I'll show you how we can create an agent that can use your browser for you in less than 20 lines of code. So on your projects folder, we'll need to create a .env file. So you can do nano.env and then add your OpenAI API key there. So this is the format that you need to add to the .env file. I won't cover that because all of this basic setup of Pydantic AI is already covered on my other video that I'll leave the link in the description. But then you'll need to also install pip install Pydantic AI and then python.env and async.io. So these are the packages that you'll need to run this little project that we have. So I've created a main.py file, and in here we can import from Pydantic AI import agent, and also we will need Pydantic AI.mcp, and then from this package we'll import MCP server stdio. And then here you can see it's also loading the environment, so we can get our OpenAI API key loaded into the environment. So this class, MCP server standard IO, is one of the ways that we can interact with MCPs in Pydantic AI. We also have the alternative of using MCP server HTTP, which will use HTTP server-side events transport to communicate with these servers. This is useful if you have a server that runs on a port, or if you have an externally hosted MCP server that you need to pass in the URL. So then you can configure it like this. This is the documentation for that. You have to import MCP server HTTP instead, and then pass just the URL of that MCP server. But in this tutorial, I'll be using the standard IO transport because that's the most common way of implementing it, and that's how Cursor or Windsurf or all of these IDEs have implemented the MCP server handling. So okay, besides importing this, we'll need to create our MCP server definition here. I will be using this MCP called BrowserMCP. This is the simplest way of adding browser use to the AI agents that I have ever seen so far. So the way this works is we have to install a Chrome extension here. So you can head over here to Setup Extension, click BrowserMCP extension, and this will take you to the Chrome Web Store. Then you can add it to Chrome. I have already installed it, of course. Then here on your extensions, you can click on it and you'll see a connect button. What this will do is use the debug mode of your browser, the Chrome DevTools, to connect to the MCP server that we will need to run locally here. So to run the MCP server locally, this is a Node.js server, so you will need to have Node.js installed. I'll leave the link to install that in the description as well. But this is basically the command that we need to run. Okay, so npx, and then the arguments browserMCP /mcp at latest. So let's just try running that on the terminal real quick. And you can see it will download the package on npm, and then it doesn't output anything to the terminal, but it is running. So if we click here on our extension and click connect, you'll see this badge pop up showing that the browser MCP is actually connected to the server. So to add this to Pydantic AI, it's very similar to what we do in Cursor, for instance. So let's create a browser MCP server. That'll take the MCP server stdio class. That'll be an instance of this class. And then we just need to pass the first parameter as the command, which is npx, and then we need to pass the args as a naming parameter, and those will be an array. All right, so to create our agent, we'll need to agent equals agent with uppercase A. This is to instantiate the agent class of Pydantic AI, and I'm gonna use the GPT-4o mini model here, and we need to pass this MCP servers parameter, and this will be an array with all of the MCP servers that our agent has access to. We will need to use async.io for this. So let's create an async function called main. And this line right here, sync with agent.run MCP servers. This means that it will go through all of these MCP servers that are in this array and run these commands in the background. So it will actually start and run the servers on the background for us before it starts the agent. And here I'm just getting the user input and passing it to the agent. Really simple. And then we can do sync io.run and call our main function. Okay, so 20 lines of code. Now let's try calling this agent and telling it to open Google and browse for Pydantic AI news. And let's do Python main.py. This will start our MCP servers on the background. And now it's waiting for my input to run the agent. So here on the browser, we need to enable the extension again. Remember, we need to connect here to the server. Here we see the badge. This means that it's connected and it's listening for commands. So this is an instruction that GPT-4o Mini wouldn't be able to perform by default, but since we have extended it with this browser use agent, it will be able to actually open Google, as you can see here happening in real time in our browser, and search for Pydantic AI news. So this is how easy it is to add an MCP server to your Pydantic AI agent. Honestly, it couldn't get easier than this, to be honest. One way I like to organize my projects is to create an agent class and then create a bootstrap method on that class that will set up all of the servers, everything, and then we can call that bootstrap class on the constructor. So here we will need to do class browser agent, and then in our init we could call an internal method like bootstrap agent. Creating our bootstrap agent method, here we will define our MCP servers. So BrowserMCP server would go there. Maybe even the load.env can be inside that. And then here we have a run method, which receives a command as a string. And we can wrap the self.agent.run with this self.agent.run MCP servers. But actually, I don't want it to be starting and closing the servers on every message that we sent. So let's create another method called sync def start conversation. But inside here, let's do while true, and then we can keep getting any input from the user and running that with our agent. Let's say if command equals exit, let's break this loop, and then let's say response equals await self.agent.run command. Then we can print response.data to see the response that this agent returned. So let's take this out of here. Okay, so we can delete our previous implementation of this. And now we have only our browser agent class. So now we can instantiate it. Agent equals new browser agent. And then we can do a sync io.run agent.start conversation. So now I have a slightly more complex conversation loop that will take in multiple messages. So if you do Python main.py, now we need to connect the extension to it. So let's say open Google and browse for nicholasleal.tech. Let's see if it finds my blog. Alright, so the response we got from the LLM is that it navigated to Google, searched for nicholasleal.tech, replied with the Google search result, the first Google search result that it found. It's very nicely formatted in Markdown, so we could easily do other actions following this. But since I clicked the link myself, I want to tell it to open this GitHub link. Let's see if it's able to perform that task. Click on the first GitHub link in this page. Let's see. Okay, you can see the cursor going there, and it clicked on the GitHub link. Okay, so this is pretty good already. But what I want to do now is add a persistent session storage to this browser agent class, and I want to do it using SQLite 3. Let's actually try to vibe code this feature. One thing I know that is a requirement for that is that I need to create new history equals response.all messages. Or actually, I'm going to use just the new messages to not overwhelm the context window. So then we need to have an internal tracker of the history. So self.history will be an empty array for now. And then after every iteration, self.history will become the new history. So when we call self.agent.run, we need to pass the current history here. And let's open the cursor agent to help us out, to help us implement the SQLite session storage. Okay, so I added this prompt here. I wish the browser agent defined in main.py had a persistent list of sessions from my conversations. It would ideally be implemented using SQLite 3, and when starting the application with Python main.py, it would first ask me if I wish to continue any previous conversations, if there are any. listing all of the past conversations for me to choose one. Then I defined the schema of the table. I said the saved sessions in the DB should have the following columns: ID, which is a UID, created at, the timestamp, and data, which would be a JSON with the conversation history. So in Pydantic AI, we have this way of storing and loading the message history as JSON using this model messages type adapter. So I'm just going to copy that documentation link and add here as relevant documentation for achieving this. Paste the link. Let's see what Gemini 2.5 cooks for us here. Let's review its implementation. Let me close this here. It calls setup database first and then bootstrap agent. Setup database, I'm assuming, is the migration, right? Okay, so it creates a table sessions if it doesn't exist. That's good. Create with the exact fields that I asked it to. So our bootstrap agent remained the same, but then he added some other methods. Load sessions, which is just a query on our database to select all of the sessions in order by created at, and it has the load history that loads a single history from the DB using the ID, then parses it from the JSON using the model message type adapter. This is correct. This actually looks pretty good as an implementation. It has a start new session method, generate a new UID, set the history as empty for now, add the created at as now, and insert that into sessions, and then start it. Shouldn't it return the session ID? Oh no, because it's setting it in the self.session ID, so that's okay. And then we have the save history, which would just update the row in the database that has the same session ID with the updated history. And lastly, it updated our start conversation method to actually load the sessions first, and then if there are any sessions, it'll ask if I want to choose one of these sessions to continue. Then it will enumerate the options here with the index +1 and then the session ID for me to choose. It's good that it also shows the created at, because no one's gonna memorize the session UID of their past conversations, but the date is easier to remember what the session was about. So here it gives us the option of starting a new session or loading one of the chosen ones here from the list. Okay, it's validating the index that we choose against the list of sessions that we found. Then here what it does is it gets the session ID from that selected session, sets it as the current one, and does the same with the history. It loads that history into the context, but then it only displays the last message. Okay, so it's finding the last agent message and printing that so we have a rough idea of where the conversation was at. Okay, this should be okay for now, but then afterwards I want to make it print the entire conversation history. But let's see if this even works. Okay, no existing sessions found, so it created a new session. Let's connect our MCP extension again. All right, so let's say open google.com, search for Hacker News, and click the first result. Okay, there it is. Open google.com, search for Hacker News. Let's see if it clicks on the first result. Okay, there it is. Now let's try asking just a random question here, like tell me a joke, something that it shouldn't delegate to the MCP server, and see if it's smart enough to do that. Okay, so we got an answer. Why do programmers prefer dark mode? Because light attracts bugs. Oh man, this is terrible. But okay, so we can exit the application here, and if we open it again, it should list our previous sessions. And now we have existing conversation sessions, and there's our previous one. All right, so we can try opening that previous session again. Here it printed our last agent message. So let's ask, what have I asked you so far? To see if it remembers the previous messages. Okay, so here it has access to our history and remember